From the dawn of computing to today's era of deep neural networks, our journey through large language models is a tale of human ingenuity, relentless curiosity, and transformative breakthroughs. This is the story of how machines learn to speak our language and, in the process, change the world. In 1950, British mathematician Alan Turing posed one of the most challenging questions of our time. Can machines think? His answer was the Turing test, a challenge where a machine must engage in conversation so convincingly that an observer can't tell if it's human or not. Imagine sitting at a computer, typing away, and not knowing if the mind on the other end is flesh and blood or circuits and code. This idea set the stage for everything that was to follow. Almost as revolutionary was the work of Noam Chomsky, who forever altered our understanding of language. His theory of generative grammar proposed that a finite set of rules could create an infinite number of sentences. In simple terms, the basic structure subject-verb-object could spawn endless variations, from the cat chased the mouse to a scientist discovered a theory. Chomsky's insights laid the conceptual groundwork that would later empower computational linguistics. In the swinging 60s, an early experiment in machine conversation emerged. Developed by Joseph Weizenbaum, ELIZA mimicked a psychotherapist by reflecting users' statements back as questions. Though it was driven by simple pattern-matching rules and not true understanding, ELIZA ignited our imagination and sparked debates about machine empathy and the ethics of human-computer interaction. As computers evolved, so did our methods for modeling language. One of the early breakthroughs in this evolution was the development of n-gram models, simple yet powerful statistical tools designed to predict the next word by analyzing fixed-length groups of words. For example, in the sentence, "the quick brown fox," a bigram model examines pairs like "the quick" and "quick brown" to determine what comes next. Though basic in design, these models laid the groundwork for early speech recognition and text prediction systems. The 2010s marked a seismic shift in natural language processing. Neural networks and word embeddings like Word2Vec and Globe transformed words into dense, multi-dimensional vectors. Suddenly, the relationship between king and queen mirrored that of man and woman in a way that was mathematically elegant. It was as if computers began to feel the subtleties of language for the first time. In 2017, everything changed with the publication of Attention is All You Need by Vaswani and colleagues. The transformer model redefined how machines process language by introducing the self-attention mechanism. Unlike previous models that processed words sequentially, the transformer examines all words simultaneously, assigning attention scores that determine which words are most relevant to each other. Here's a simple analogy. Imagine reading a puzzle where each word shines a light on its neighbors. The transformer's self-attention mechanism allows it to focus on key words in a sentence, much like highlighting important clues in a mystery. With positional encoding to maintain the order of words, and an encoder-decoder structure to refine understanding layer by layer, this architecture powered the rise of models like BERT, GPT, and T5. Its impact: faster training, greater accuracy, and the foundation of today's AI revolution. Fast forward to 2022, and the era of ChatGPT has transformed our everyday interactions with AI. With billions of parameters and the revolutionary concept of few-shot learning, models like GPT-4 can generate text that not only mimics human language, but understands context with uncanny nuance. These systems now power virtual assistants, creative writing tools, and enterprise solutions, bringing us closer to the dream of machines that truly converse and reason. As the field matured, specialized models emerged, each honed for particular tasks. OpenAI's Codex revolutionized programming by powering GitHub Copilot, while image generators like DALL-E redefined creative expression. Simultaneously, the open-source movement brought models like Llama and Bloom into the hands of developers worldwide. And with innovators like DeepSeek pushing the envelope on efficiency and accessibility, the democratization of AI has never been more real. Looking ahead, large language models are poised to redefine every aspect of our lives, from overhauling healthcare systems to transforming the way we learn. With innovations centered on ethical design, energy efficiency, and genuine human-AI collaboration, the future of LLMs unfolds as a canvas of limitless possibilities. The journey from ELIZA to GPT-4, and now to emerging pioneers like DeepSeek, reminds us that although we have achieved remarkable milestones, our adventure is only just beginning. From humble beginnings to transformative breakthroughs, large language models have reshaped not only how we interact with technology, but how we understand ourselves. As we continue to explore and harness their potential, one truth remains clear. The future of AI is not solely about machines, it's about us and the choices we make in wielding this incredible power. Whether it's GPT-4, DeepSeek, or the next groundbreaking model, our story is far from over.